Hello, this is Mr. Harris. I'm going over quizzes 3 and 4. Remember, these did not have to be turned in, but you should have done them. Problem sets are due. You'll have another quiz that's due. It's just a multiple choice quiz. The analysis for quiz 1 and your hypothesis tests were posted in the link just before this one. So let's begin to go over quiz 3. Sharing screen. Here we go. Quiz 3. Coordinates Centers for Disease Control and Prevention. Website, 50% of high school students have never smoked a cigarette. This is old data. This is before those vaping things. There's still much research that needs to be done. Vaping is one of those things you never know till 10, 20 years down the road. So we're going to have to wait and see what implications on that may be. Taeyeon wonders whether this national result holds true in his large urban high school. Large urban, I'm thinking 3,000, 4,000 students. Yeah, it's a lot of students. For his AP statistics class project, Taeyeon surveys an SRS. So it's not a simple random sample, it's an SRS of 150 students from his high school. He gets responses from all 150 students, and 90 say that they have never smoked a cigarette. I'm immediately thinking a proportion. What should Taeyeon conclude? Give appropriate evidence to support your answer. This is actually a question from that blue book that I wanted to transition to, but South Carolina didn't want to pay for us to buy books. So here we go. Okay, so it's a proportion. Let's walk through step by step by step. Pause the screen, take screenshots if you need. Just for those wanting to take screenshots, this is the first half. And then this is the other half, the conclusion, which a lot of you lost points on your unit 8 tests because you didn't provide conclusions. Those grades are in. I have to send everyone their individual notes. And my next video will be going over that quiz. But again, we set up our null and alternative hypotheses. The importance of setting up hypotheses, using your numbers to indicate, is it a one-tailed test or a two-tailed test? It does make a difference. Because right now, again, if you're a statistician, it takes a while to be a lead statistician. Right now, the principal investigator makes the decision for the study. In this case, technically, Taeyeon would be. If the principal investigator wants a one-tailed test, you need to do it based off the one-tailed test. If they mess up and make the wrong decision, that's on them. You make your notes, you work your way up the ranks to get enough cachet or juice, if you will, to make such decisions, but you always have to work your way up the ladder. Politics is everywhere, no matter the job you work at. So we're here. Generally, I'm thinking proportion. Taeyeon told us it's a 90 out of 150, so that's some other proportion, a little bit more than 50%. With proportions, the status quo is always 50-50, like flipping a coin. That's what you always assume, that it's no difference than anything else. It's 50-50. Even if they didn't give this 50%, you would assume it's 50-50. Either you are smoking or you're not. A binomial variable, 50-50. Thankfully, they told us it's 50%. If they tell us it's something different, we got to go with that. But if they don't tell you proportions, please stick with 50-50. Alpha, we're willing to live with an error of 5%, which is very generous considering his study. I would go for more 10% because it's so much inherent error in this, and he is just doing it on his own. Remember your state, plan, do, conclude. That will help you be organized, and concludes on the other side. Make sure you do state, plan, do, conclude for all of your word problems, especially those taking the AP exam. That will keep you from making careless mistakes. Some of you guys lost 10 points because you didn't have the conditions portion, the plan portion. You need to write things out. The proper way to do it is it's random, and you need to pull some quotes from the data. You can't just say random check mark. That's not good enough for AP exams. You have to quote it from the information given. 10%, you have to write out in some degree, it seems reasonable because it's a large school in a city. So 10%, an easy way to go around that is multiply your sample size times 10 and say it is reasonable that there's more than 1,500 students in a large high school. Hopefully in an AP exam, they're going to give you something better, because it's very reasonable. I wouldn't necessarily know how many students are in a large high school unless you just live and see, but it's very possible. There's schools with like 7,000 people. My college had 10,000 people just on that one campus. What is that? Yeah. The large counts. You want to make sure your sample size is large enough. This large counts as part of the conditions for proportions. This is your n times p. You need to make sure your n times p is greater than or equal to 0. You also need to make sure your n times q is also greater than or equal to 0 to make sure your sample size is large enough. These are two separate things. This is for independence. This is relative to the law of large numbers, making sure your sample size is large enough. 75, 75, check. We need to see the 75 and 75. The do, we're doing this. Write this out if you can. For you guys doing the tests, just write it on paper and send in a screenshot. Please don't spend all your time with this word formatting, drawing lines. God bless you, but you have better things to do than to draw some lines. Take screenshots of your scratch work just so I can tell. In the actual test for the AP, you'll be able to write it down. Let's talk a little bit about this p-value. Here's the p-value, and your calculators, you would have told it it's a two-tailed test, so it would have calculated the proper p-value for you. That's another reason why it's important to set up your test beforehand. If you're doing this by hand and you're simply looking this up in your table, you would look this up and you would find a positive 2.45, so you would see a really small number, but it's two-tailed. So p-value is the area shaded to the right of your values. Because it's two-tailed, it's positive 2.45 and negative 2.45. That's why we have to always multiply our p-values times 2. This p-value is very much less than 5%, so we know it's pretty significant. Here's a reasonable conclusion. Multiplying your p-value times 2, conclude. Since the p-value, notice it in parentheses, 0.0142, is less than alpha 0.05, we have evidence to reject the null, H naught. There is convincing evidence that the proportion of all students whom would say they haven't smoked differs from the national result of 50%. Please study this. Don't copy it, but copy it. You need to be this precise. I didn't see on that Unit 8 test, no one had any writing that precise. If you don't have a conclusion, I took 7 points away from no conclusion. This stuff definitely matters, because there comes a time this calculation stuff is easy. Remember, stats is a combination of math and humanities. You need to write things out clearly and using the proper wording. You have evidence to reject, or you fail to provide evidence to reject. And that's quiz 3. I'm going to move on and discuss a few things with confidence intervals, and then discuss quiz 4. Here's my other board. Okay. Hopefully you notice confidence intervals are pretty much the same or very similar to hypothesis tests, and they may even give you more information. Here we ran this using 90 out of 150. In this case, we're not going to use the standard of 50% relative to other schools. We're just using the information from Taeon's study, 90 divided by 50. So that's our p hat, q hat. That's our n. Running a confidence interval, this is what we use, the critical value for alpha of 5%. This is the interval. This is how you would write an interval for a confidence interval. And there is a confidence interval kind of question on this coming Unit 9 test. The confidence interval in this example is much more informative than the significant tests we performed on the other side. The interval gives the values of p that are plausible. When I'm saying p, notice not the p value, just p, the population parameter, because all of this is figuring out what the population parameter p is. It not only tells you if it's significant and at what level, but it tells you potential plausible values of p. I wouldn't be surprised if the true proportion of students at Taeon School who would say they have never smoked cigarettes was as low as 52.2% or as much as 67.8%. Remember, it's all equally plausible. However, we would be surprised if the true proportion was in fact 50% because it's outside of the interval. It's not contained in a confidence interval. I'm going to show you some computer printouts for the same Taeon data. there will be a few computer printouts. Remember, your final project is essentially doing stuff through using the Google Suite. There's a very good free Google Sheets suite for calculating all of this. Sample 1, because you could have multiple samples, n divided by 150. That's your sample proportion. That's your 90 divided by 150. Your confidence interval, the good thing is you just type in the numbers like your stat edit, and then you run the tests and it just works all this out, but you have to know that it makes sense. Your Z critical value, and then it calculates the P value. Test if P equals 0.5 versus P not equal to 0.5. And then here's another printout from another different situation. Negative Z value, P value 10%. So it would not be significant at the 5% level. It would not be significant at the 10% level. This is why it's good to have simulations. Run a simulation, you would tell the principal investigator, maybe try to do 150. Increasing 150 might get it down to 9%. Okay, on to quiz number 4. That's the previous quiz, which there's a video for already. In case some of you didn't watch, well, you should be watching the video. Why am I making your life easier? Let's share the screen. Here we go. Okay. Quiz 4, Sports Illustrated. In this case, you were given the null and alternative hypotheses as an example of what things are, properly labeled. H sub A or H sub 1, it doesn't matter, use either or. This is what your A and B should be. I'm gonna let you just look at it, maybe take screenshots. And this is the last bit for C, and here's a bit of notes about students I've seen in previous classes and issues with what they've had with this response. Yes, you have to count up all the dots. Generally, it's around 100 if you don't feel like counting or if you're miscounting. Numbers are also here. Assuming all 30 teams are equally likely, 19 seasons. That might be 30. I'm not sure. It's been a while since I've done this one. I didn't want to do this again. If you have specific questions, we've done similar things like this. I think most of you would have gotten this right. This C is really the main reason why I posted this. Finding this locator, there's only one dot right here. Yep, it's 100. We want to figure out what the p-value is. It's 1 out of 100. We reject H naught because the p-value is like 1%. Yeah, this case, you don't need the traditional z-test because we're just looking for proportions. The z-test gives us the proportion, but we don't need that because we can just count the dots. Let me know if you have questions. Tutoring's again tomorrow. Problem sets due. Test next week. Have a good day. The next video will be going over your Unit 8 tests. Stop sharing. Goodbye.